Good evening, Antonio. Are you well?
Perfectly fine, thank you.
Good. So, Antonio Martin Carrillo is a UCD Ad Astra Fellow, Assistant Professor in the School of Physics. He graduated with a BSc and MSc in Physics with Astronomy from the University Complutense in Madrid, if that's the correct pronunciation.
Perfect.
Following 2 years working at the European Space Agency as part of the XMM Newton Space Observatory collaboration team, he moved to UCD, University College Dublin, where he completed his PhD investigating gamma ray bursts and pulsars. He is currently a member of the Space Science Group studying the transcendent universe and in particular the prompt and afterglow emissions of gamma ray bursts using high energy space observatories and ground-based telescopes such as UCD's Watcher Robotic Telescope. His research also includes the development of software tools for advanced data analysis. As such, he is an ambassador and collaborator on the Astrophy project aimed at providing a wide range of software packages written in Python for the use in astronomy. He is also a member of the Integral multi-messenger group searching for gamma ray counterparts to gravitational waves, neutrino events, and other transient sources. The Athena X-ray Space Observatory and ESA large mission scheduled to launch in 2028, and the Thetis Space Telescope, currently in its study phase with ESA. So please put your hands up and welcome Antonio Martin Carrillo.
Hi, thank you very much. Thank you very much, and I'll be happy to talk about my science at any given time. So if you want me back, I'll be happy to be back. So just I'm offering myself. It's a pleasure. It's an honor to be here. Thank you very much for inviting me. I'm just delighted. Sorry I cannot be there with you in person and to chat. But you know, technology sometimes is kind to us, and I can speak from Ireland. I mean, just neighbor. So I'm a scientist, as Steve has said, and it's multi-wavelength. That means I do optical, X-rays, gamma rays. I use everything that I can. And on my free time, meaning for outreach and for teaching purposes, I do a lot of astrophotography. And that's one of the things that that's the thing that I'm going to be talking about today. I'm going to be focusing on how to photograph meteor showers, which is one of the most difficult or more challenging type of astrophotography that we have, but also some of the most rewarding once you get it right. And so without much introduction, let's see. I hope you can see now the slides. Can you all?
That's brilliant.
So Sky Wonders is my astrophotography project. It's about explaining the science in astrophotography, and not only how to do astrophotography, but what's the science behind. And currently building a book or writing a book, and UCD, that's the place where I do all my science and my teaching. And so today I'm going to talk about how to photograph a meteor shower, and the first thing we need to do is, what is a meteor shower? Some of you may know, hopefully everyone, but just to put everything into context. So and by the way, all the images that you're going to see here, they're all mine. I've taken them all. So if you want to ask how I took technical aspects of those photographs later on, just feel free, because they are all mine. So when a comet is essentially, we call it a dirty ice bolt. So essentially it's a lot of ice with something else. And when they get really close to the sun, they start this process that we call sublimation, which is just essentially a fancy word to say they go from ice all the way to gas without being liquid. So they skip the liquid part. And when they do that, they get really, really bright. And the closer they get to the sun, the brighter. And if they get really, really close, as we saw a few years ago, I think now it's about 8 with Comet Ison, it got really close and eventually just destroyed it. But if we're lucky, we might have things like this case, like Comet Neowise last summer, where we have gigantic, beautiful tails. Normally, the one that we see bright like that is the dust tail, and the dust tail, well, is leaving behind a lot of dust, as the name indicates. And we're talking about it could be even millions of kilometers long, so it's really, really, really long. And it reflects light, interacts with light, it scatters light, and it can get really, really bright, especially around the closest position to the sun and a little bit farther out. In this case, it happened that everything worked really well to see it even naked eye. And then there's the ion tail, which is just charged particles. That one is a little more difficult to see. Definitely for Comet Neowise, we needed to see it when the sky was a little bit darker. And that one, just to give you an indication, it could be one astronomical unit long. That means that the average distance between Earth and the sun. So it could be that the comet is on the other side, extremely close to the sun, and still the ion tail, some of those charged particles could hit us. Not that it would damage us much, but yeah, it's a nice fact to have there. Now, but the important thing is that the dust particle that is left behind, it tracks the motion of the comet. It continues the path of the comet. It has slowed down a little bit because, of course, the comet is going in one direction, and these dust particles have been ejected from the comet. So in the relative motion, they're not going to go as fast as the comet, but they will go behind and they will follow the same orbit. So after millennia, what you could have is that the orbit of a comet is covered by dust particles all around. And this is what is going to generate the meteor showers. The comet can cross the orbit. I mean, this is a 2D, so in 2D, we can see 2 points where the comet can cross the orbit. But in reality, we have to think on 3 dimensions. So it could be that it only crosses one. It could be the one on the left. It could be the one on the right. No more than 2 points. For example, Comet Halley, we have 2 meteor showers coming associated with this comet. But most of the meteor showers that we know just give most of the meteor showers corresponds to just one comet. So it is at those intersecting points where we enter this swarm of dust particles, the size of a centimeter, most of them, really, really teeny tiny, or even smaller than that. But there are loads of them. And, it's when we have these amazing events and dramatic scenes. Now, depending on how we cross that swarm, it could be that we cross it from the side. It could be we cross it, like the universe, or the way Earth is spinning around the sun is not exactly fixed like you would fix it with a pole, attaching a ball to a pole and making it move around. It wobbles a little bit. It wobbles up and down, what we would consider up and down. It wobbles a little bit in every direction. So sometimes we would cross the swarm of particles really, really on the edge. Sometimes we will go through it perfectly. Sometimes there will be more dust, and sometimes there will be less. So that will change the duration of the meteor shower, the intensity of the meteor shower, both things. And from the point of view of space, of course, the particles are just traveling through space, and it's Earth that is coming to them. But from our point of view, what it looks like, as you can see there, is like they have a common origin. That's what we call the radiant. And the radiant is associated, or from our point of view, the radiant falls into one constellation. So the meteor showers received their names not because of the comet, but the constellation where the radiant seems to be. So in this case, we have the Perseids. So Perseus is there. You can see the double cluster just about there where my mouse is pointing. You would see the double cluster of Perseus. And on the top right, you would see Andromeda. And this is just a 24 millimeter image, just 20 seconds or so. Now, what you can see also is that the trails of the meteors change far away from the radiant. They are much longer, and that is explained because they're coming at a much shallower angle, so you can see them pretty much from the side. So you can see the whole trail, the whole interaction with the atmosphere. And in the direction of the radiant, they come really perpendicular to you, so that the trail is going to be really, really small. So that's something to think about. As an example, here, for example, we have a close-up of one meteor that passed by near Andromeda. And again, that's not the full size of Andromeda because it's just a 20-second or a 10-second exposure. But Andromeda is a huge, it's big in the sky. It's much bigger than the moon in that sense. And we can see that there was a meteor much larger than it. And that was decently close to the radiant. If we go farther away, like on the right side with the Gemini meteor shower, what we can see is trails of the size of a whole constellation. I hope you can see that this is Ursa Major, the main part of Ursa Major, the Big Dipper, behind one telescope in Tenerife, at the observatory of Tenerife. And you can see that some of these trails are as big, some of them not much, but some of them are huge, humongous. And that's again, when we are planning, when we want to think, oh, I want to photograph meteor showers, and this is something that we really need to consider. That's what is going to make it more spectacular, more interesting. So let's go into the planning on how to photograph the meteor showers. The more you plan ahead, the more success you will have. There's no doubt. That's a general situation for any astrophotography that you want to do, but for meteor showers it's even more important, because at the end of the day you just want to take thousands, and I'm going to say not hundreds, but thousands of images, and you don't want to be messing around much. You just want to decide in advance where you're going to point, trust your planning, trust your instinct, your knowledge, and just take shots constantly, boom, 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 boom. Because you can't just check, oh, I'm going to check if a meteor happened, because when you're checking, maybe one will happen just in the frame. So you just need to trust what you're doing. And if you have more than one camera, like luckily for me, for the Gemini meteor shower of 2018, I had 3 cameras. Canon lent me the new EOS R for testing. I had the Canon 80D, which is an APS-C, it's a crop sensor camera, and I had my 6D. So I had 3 cameras spread around all across the observatory. And I set them up. I was stressed setting them up, but once they were there, I just enjoyed the meteor shower because I knew that I had done a very good planning, and the cameras would just be doing the rest. Of course, you have to check the batteries, you have to make sure that things are still running, so I would be walking, but so let's talk about planning. So there are few desktop free apps, or cheap, I would say, not very expensive apps, like Stellarium. That has been my go-to app on desktop on a computer for years. It's free. It provides so much information. It's very powerful, but I find it that it's a little bit slow sometimes because it's an open source project, because it's made to run on any operative system. Is not very well optimized, and sometimes it can make the fan really spin and be loud. So I tried Sky Safari 6, which has different payment options, and I kind of enjoyed how my computer deals with it, but they are quite comparable in that sense. And then I'm going to talk about Photopills. I don't know if anyone knows it well, but I'm going to go really detail about what Photopills can do for you in meteor showers. Not because they pay me. Yes, I know them, but it's really, really the app that I use. This is my own use, and this is my own experience. As I said, this is not an advertisement or anything. It's truly my honest opinion. And it's you paid, it's for the phone, it's Android or iOS, and it's just fantastic. And of course, don't forget to check if the weather is going to be clear or not. So a few of my most favorite apps, iOS, computer based and phone are there. So those are my most trustworthy weather apps. So this is how Photopills would look like. I kept it to the 2020 meteor showers for a specific purpose. I didn't change the screenshots here because last year there was a few nice conditions, and to show the effects of the moon, for example, it works better for 2020 than 2021. So you have here the time, for example, the time left for the moon to rise. You want to avoid the moon. You want to avoid having the moon out there. The moon is just going to make the sky brighter. You're going to see less meteors, and yeah, something that you don't want. And then at any single time, there are multiple meteor showers. So in this case, for example, you see that we have the Perseids, but at the same time, there are other minor meteor showers going on. So that's something important to think about. And later on, when you want to do your final image, you might actually have some imposters there. One thing that I like from Photopills, and it's something that I had to email them and had a deep conversation with them, is what is the current value. So they provide an estimate of the meteors per hour per minute. So as you change the time here, it was midnight, 22 minutes past midnight, and they were giving me an estimate of 61.7, and I could change per minute, and that estimate will change. And I noticed that at peak time, it didn't correspond to what I saw in other places. And normally, the meteors per hour that pages like the International Meteor Organization and so on gives you are the meteors that you would see in perfect conditions, perfect darkness, straight up in the zenith. And that's not normally what happens. The radiant is normally not in the zenith. The radiant is normally somehow low in the horizon, things like that. So Photopills takes all this into account. It takes into account if the sun is only about 10 degrees below the horizon, and it could have some effect in the atmosphere. If you have some kind of moonlight, they are now, and I'm working with them on introducing light pollution. So there are maps of light pollution, and we are going to work on introducing how that would affect the estimation of meteors per hour. So it's a more realistic number rather than the zenith rate of meteors per hour. So I really, really like. Now, if you swipe down, you even have more information. So the information doesn't end there. This is what I wanted to show you. So there's two clear messages here. The first one is that you can see that, for example, in the Perseids, the peak on the 11th of August, 13th, well, I missed the 12th of August because, yeah, if it's 11th and 13th, you can assume that for the 12th is valid. So for the 11th, the 12th, the 13th, the 14th, the peak is kind of similar-ish. So if you want to go and enjoy or photograph the Perseids, you can go almost from the 10th or the 11th all the way till the 14th or the 15th. It's a meteor shower that allows you to have many different attempts to enjoy it or to photograph it. To have at least one of those nights cloud-free, you know, living in Ireland, and probably quite similar for you guys, you know, we really loved our cloud-free nights, which are not that many per year. So, you know, the Perseids is one of those meteor showers that we could have a chance. Last year, for example, I did have a chance. That's the first message. The second message is look at the graph. The graph shows an increase on the rate. Is showing you in gray the rate of meteors per hour that you would expect. And it shows rising as the night progresses. And around midnight, it drops drastically, and it drops again. And here on the last night, it doesn't drop as much. That drop is because the moon was rising. If you can see, the blue dot indicates the time at which I was kind of calculating the rate. And if you go up, it says that the time with no moon, you have 15 minutes left of no moon. 15 minutes later, the moon is going to start rising. And that is the effect of a moon, which it wasn't only, it was kind of like half a moon. This is the effect of the moon. It just drops. The number of meteors that you would see per hour, it just drops drastically. So it's very important to try to avoid the moon. That's why the Gemini meteor shower last year was an outstanding, well, you know, it was a great opportunity. I mean, it was cloudy here, so I didn't get to see it, but it was a great opportunity because there was a solar eclipse. So we knew that the moon was with the sun, so there was no moon at night. So it was a great experience. Now it also tells you the azimuth, so where the radiant is at that specific time with respect to north, and the elevation. So it will show you if the radiant is way above the horizon or close. So for example, here at that time, it was about 36 degrees above the horizon and 38 degrees 0.5 in azimuth. So you can then start planning in which direction you should be shooting at. If that's not enough, you can press the AR button, and then, I mean, this is in the middle of Dublin, so not helpful, but essentially just overlays your camera with where the radiant is going to be. So you can actually then even, you know, if you want to go to somewhere and have some foreground elements, you can find the right composition using Photopills. And because it's in your phone, you know, you can actually bring it out, you know, to the field, to wherever you want to go. So this is why, for me, Photopills was, since 2017, a game changer on the way I approach meteor showers and my success, actually, on imaging meteor showers. Not only that, you can also overlay a Google map, and you can say, well, I have this camera with this lens, and my focal point is going to be at 135 meters away. I'm going to shoot portrait, and it tells you, well, your field of view is going to cover all this. So you can see how much the radiant is going to move. So the radiant is this dots over here, and the radiant was going to move like that. So I knew that eventually with my composition, I was going to lose the radiant after a while, but for most of the time I was going to have the radiant. That's important because you don't want to move too much the camera. You want to be steady there and keep the camera taking pictures as much as you can. This is a result from last year from the Wicklow Mountains at the south of Dublin. This was a risk. I went completely opposite, pretty much 180 degrees from the radiant. The good thing is that the trails are going to be huge. The bad news is that you're probably not going to see many meteors because you're really looking opposite. But I knew that with Photopills, I knew that the Milky Way was going to be there. So I pointed the camera and left it there for a couple of hours, and I got the chance of seeing two. I mean, this one, it was impressive, but yeah, there were two quite bright meteors, and I was able to keep the color, the green color. The green color is the interaction. So when this particles, centimeter, really teeny tiny, interact with the atmosphere, they can generate up to 1,000 degrees. So really, really hot temperature, a few thousands, as a matter of fact. And that temperature is gonna excite the elements in our atmosphere. Depending what elements, you might see a green color or you might see a red color. This is very similar to what auroras do with the atmosphere. You have charged particles interacting with the atmosphere, exciting the elements, and we see sometimes a green aurora, sometimes we see a red aurora, and it's the same reaction. Here it just happened in a flash. In auroras, it happened much broader and for longer of time, but it's very, very, very similar process. So sometimes you can take risk, as I did, and like leave the camera there for a very long time, and okay, I got two, but at least it was a different composition. I went for something different, and I got it. I show you that the proceeds are very forgiving. You can just go multiple days. There's the opposite case, the Geminids. They are on the date, or you miss them. So I'm going to show you the same diagram here, the same captures. And this is pretty much the same every year. On the spot, on the 14th of December, you see the peak. The peak is going to be over 100 meteors per hour or close to. And one day earlier, you end up with about 20. One day after, you end up with 20. Now, should you go? Well, yeah, I mean, if you can go. I mean, this year for some reason the night before was a little bit more active than we expected. It could be that we pass a second arm of the swarm of particles that we didn't anticipate it. These things happened. So if the sky is clear and you're around the peak and the moon is good, I always say try it. You don't have anything to lose. 28 meteors per hour. Well, it's nothing really super dramatic, but it's interesting. It's more than most of the major meteor showers. Now, the Gemini is the meteor shower of the year. I know the Perseid has a lot of name. It's just it happens in summer when the weather is better. But the Gemini, it's there's no other meteor shower like this one. If you pick it up, if you get it without moon on the peak night, the experience is, and it has happened to me twice now, it's overwhelming. And I'm an astro lover. I wanted to be an astrophysicist since I was 8, and I can tell you, and it's a little bit embarrassing to a certain point, I had to go inside of one of the telescope domes and relax for at least 45 minutes because my heart couldn't hold it anymore. It was like another one and another one and another one and another one. I couldn't just, I was looking everywhere, just enjoying it, but it was too much. They were so bright, some of them, that they were lighting up the domes. And it was so much that in the morning, the day after, a bird flew by on top of my head, and my brain just, I caught it with the side of my eye, and my head just turned like if it was a meteor. Like for 2 days, I was like on the edge constantly, and it was that much. It was very intense, and it has happened now to me twice, and in average, it's the meteor shower. Now it's cold, very cold, but it's the meteor shower of the year. So my advice, if you want to see with your eyes or to photograph them, is try to avoid moon as much as you can. And for me, I would say the radiant high in the sky. That would allow you to have much wider area in the sky to cover. Now, a lot of people will tell you, that the radiant close to the horizon is really good. And that's kind of true. If the radiant is close to the horizon, all you're gonna see is the shallow angle ones, so the ones with a long trail. But you're missing half of that. You're missing the ones that are going on the below the radiant. So you're only seeing half of the meteor showers. It's like going to let me go back. It's like going to this image where the radiant was rather low and cutting it in between, and you will be missing 1, 2, 3, 4. Well, that's not a Perseid, but you would have missed it anyway, 4. And then this 2 would have been within the light pollution, so you wouldn't have seen it. Or maybe even this 3 would have been within the light pollution, you wouldn't have seen it. So if I would have started of this image would have happened with the radiant really, as some people suggest, at really low on the horizon, I would have seen 4, and my image would have been 4 coming up like that. It's not visually appealing. It's not nice. So I would say something like this is a little bit nicer. It's above the light pollution, and definitely it allows you to have that zoom effect, that like if it's immersive towards you. Okay, so that's it for that. This I have updated it with the values for this year. Bad news, there's no really major meteor shower this year with no moon. The Perseids are gonna look decent, 23% of the moon. It means that it will affect us. I didn't check it, but it will only affect us half of the night. So I don't know if it's the first half of the second half, but it means that we will have half the night. We will have half the night to enjoy the meteor showers. So at least that. And these are the what you would find from the IMO, for the International Meteor Organization. This is the realistic peak that Photopills, for example, was giving me here in Dublin. And so you can see that it's much lower, but still for the Geminids and then the Perseids is quite high. And this is taking, for example, the Geminid case, it's even considering the 80% moon phase. So quite impressive. One thing, as I said, meteor showers are a little bit unpredictable. The Draconids, they are very unpredictable. And I think it was 2019 when someone went out and counted 150 meteors per hour, and everyone was like, what is happening? So yeah, that one, there's no actual, normally it's very poor, but it could be very impressive. The Leonids tend to be quite low, but again, last year they peak a little bit high. So my view is, if there's a meteor shower and around the peak night, and I put the night of the peak, that is the night going from the 21 to the 22, or from the 5th to the 6th, and et cetera, et cetera. If you can go out and you won't just go because you never know what the show can do. And for the Geminids, I said it like last year, 2 days or 1 day before peak, someone reported a huge number from the northern side of Ireland, and it was impressive. I mean, it was hard to believe. Now, one thing that a lot of people will not mention to you, and because we are talking about photographing them, is the speed of the meteors. And the speed is really important, because if you have a meteor shower like the Perseids or the Orionids that are traveling really, really fast, like 70 kilometers per second, it means that they are very short-lived, that they're going to travel a lot of distance through the sky, and if you want to image them, they're gonna expose a lot of your pixels. So the amount of light per pixel is going to be very, very short, because they're going to cover a lot of them in very short amount of time. So they're going to be more challenging to photograph. If you have a meteor shower where the meteors travel much slower, well, they are a little bit long-lived. Even if they travel a lot of distance in the sky, well, they travel slower, so they are more paused, and you can image them a little bit better. It means you have a more realistic, effective exposure. Why do we see different speeds? Well, it depends on how Earth enters into the swarm of dust. If Earth is rotating towards the swarm, we would have we would be encountering the dust particles. That means that it's like two cars traveling in opposite directions. So the relative velocity is really, really fast. But if we encounter them, so that would be, let's say, during sunrise. So kind of like the peak will be happening more towards the morning. If what we have is an evening shower, kind of more like Geminids and so on, that means that we enter from behind, or the swarm enters from behind. We are moving in the same direction. So it's like a car overtaking another car. So it takes a little longer for the car to overtake us, or for us to overtake the car. So the relative speed is much slower. And so that's the difference between one and the other. And it makes the Geminids, again, better in the sense that they are much, much lower meteors. And the Ursids, which is another quite interesting meteor shower, it makes it much lower. By the way, I considering there's another major meteor shower in January, I omitted it because it has already passed. I could have put the 2022, but I just put the remaining meteor showers, so I didn't put the one in January. So remember that at any time you might have intruders, and that's important when you want to do the composition. Here, well, I didn't have too many because we had clouds rolling in, but normally you would want to avoid having a meteor that doesn't come from the radiant. It kind of destroys the scenery a little bit and the effect. So just keep that in mind, that sometimes if you're creating your final piece, your final image, and you see a meteor that doesn't match, it's not that you're doing anything wrong. It could be that it's not from your meteor shower. Let's go and talk about equipment, and after that I'll show you some of the images that I've taken, but this explains why those images are like that. And the key thing is, photographing meteor showers destroys everything that you may know about astrophotography. Why? Because in astrophotography, normally we want to expose the most, as much as we can. If we have star trackers or tracking mounts, we use them, we track the sky, and we expose for as long as we can with the stars being round. If we don't have star trackers or tracking mounts, we use the 500 rule, where you divide 500 divided by the focal length, or 300 if you're like me and more conservative, and you expose for as much as you can due to that rule. Why? Because the sky is fixed, and if you expose the longer, as that histogram is showing you, if you expose the longer, you will collect more light, and therefore your stars are going to look better. But in meteors last about a second. So they don't care if you expose for 1 second or 10 seconds. That light was there for 1 second. So If you increase the exposure, yes, you're making your scenery better. You're making your foreground looks better. Your sky will look better, but the meteor actually will look the same, or will, if you have a background, it can actually start looking dimmer. You might actually lose the meteor because the background is not dark. And technically, there's no place on Earth really with dark black skies. And if you have a moon somehow rising, that's even more important. So as this shows, by increasing the exposure, your background, your sky, will also increase. So if you compare the height of the amount of light from the meteor versus the amount of light from the sky, well, it was better when we did the 1 second. So not saying that we should expose for 1 second, because that would be too short, but it's not about exposing for a long time. That's the key. In this case, you have to know your equipment and make an informative decision. And hopefully with this, I will help you getting an informative decision. So what your lens, how much light your lens can get is very important. And you want a lens that is very luminous, that is very sensitive to light. Technically, so the reason for that, I forgot about this slide. The reason for that, and I mentioned it before, the true exposure per pixel, when you put the pixels there on your detector, and you see that the meteor has crossed multiple pixels, 1, 2, 3, 4, 5, 6, 7 pixels were exposed in 1 second. So technically, the exposure per pixel is 1/7 of a second. So even if you expose for 1 second, you didn't get 1 second worth of signal from the meteor because it was crossing multiple pixels. So again, it makes it a little bit difficult. And you want a lens that is very luminous, that you can capture a lot of light. For that, what we need is a big aperture. So a lot of people talk about f2.8. Oh, you need a lens of f2.8. That means absolutely nothing really. Because if you divide 14 millimeters, which is a really nice wide angle focal length, by 2.8, you get a teeny tiny aperture. But if you get, or if even with the 24 millimeter, if you put 24 millimeters at f2.8, you get a teeny tiny circle. But if you put it at f2, suddenly you get 12 millimeters. You get something much bigger. And the difference is that if you have a 24 millimeter f2.0 versus, which, as I said, gives you 12 millimeters, versus something that gives you about 6 millimeters, you are 36 times more sensitive. So in the same amount, what this means is in the same exposure time, you can detect things that are 36 times fainter, which is what you want. You want in a very short amount of time to collect as much light as possible. And that's what you need to try. So wide angle lenses are great because you say, well, I can see all this. So I'm hoping that because I have this gigantic field of view, a meteor will fall there. And that's why a lot of people try to go to the 14 millimeters. I'll show you a result with a 14 millimeters. It works, but some things look a little bit dull. With a 24 millimeter, even a 35 millimeter, you still get a nice looking foreground and a nice field of view. But now you're bringing the meteors to you, you're increasing your sensitivity, and you will have much more luck. So when you see lenses between 10 to 60 millimeters, they tend to be at f2.8. As I said, they're 14 millimeters f2.8. It's just a 5 millimeter aperture. 5 millimeter. Just make a circle. If you have I don't have it right now here, but if you have the Samyang lens, like put it at 2.8, and you'll see, it's 5 millimeters something. It's tiny. But then if you put the 24 millimeter at 12, you see a circle, big circle. The difference is very noticeable. Even the 24 millimeter and f3.5, technically, for meteors or for meteor showers, will be slightly more sensitive than a 14 millimeter 2.8. Now, this is true, and this message is for meteor showers. Remember, I said photographing meteor showers is completely different to normal astrophotography. If you were doing normal astrophotography, the fact that with 14 millimeters you could expose for longer, it will be much better. to have a 14 millimeters f2.8 versus a 24 3.5. But because here exposure is not playing a role, you're essentially going to expose the same with a 24 or with a 14. In here, this becomes better. So in general, my recommendation is 24 and 35. And if you have an APS-C camera, like if you have a crop sensor camera, you can, it's the same, it works in the same way. It's just, you just get, you're multiplying. So essentially the aperture remains the same, but you're multiplying both factors, the focal length and the f2.8 or whatever you choose. So the real aperture, the real size remains the same. You just reduce the field of view. So let's say that you have a 24 millimeter, 1.5 crop factor. Well, it's equivalent to a 36 millimeter. That falls within the range that I'm in. Now, technically, with a 35 or 35 true f2.0, you will have better sensitivity. So technically, a true full frame camera will use better that lens or than a crop lens, but you can do it. And I have success with my ATD, which is a crop sensor, and I have success with my full frame. So you can do it with either. So what is the exposure times? So if you have a very luminous lens, like the 24-35 at f2 or so, and a very dark skies, you can expose for 8 seconds, 10 seconds, and 12 seconds, no more. But that's about the 500 rule. If you don't have dark skies, or you don't have good luminous lenses, yes, expose less, because then you're gonna go into trouble. The background might be too high, and eventually, as I said, it doesn't matter. So 5 seconds would be my minimum. I would not go less than 5 seconds, because divide 1 hour into 5-second intervals and you go crazy. So you know, we're gonna end up with, imagine, you know, that example that I gave you about the Gemini meteor shower. I had 3 cameras exposing about 10 seconds each, and I had the whole night. So then I had to go one by one through all the images that I detected. I can't remember, it was something like, I can't remember, it was 3,000 images or more that I had to go through. And then you have satellites, and satellites are easier to spot, because you will see that the satellite appears in consecutive images. So you're like, okay, you know, this is a satellite. I saw it in an image before, I saw it in an image after. That's rule out. A meteor will only be in one single image. The afterglow, or the dust that it leaves the trail, sometimes can be seen in multiple images, but what you will see is that emission constantly almost in the same place. Satellite is very easy because it really moves across the image, from across the field of view as you move through the images. So for example, last year I saw, I couldn't image it, but we saw a gigantic fireball that exploded, and then the dust just remained there for a minute and a half. If I would have been exposing it, I would have caught that perfectly. It was visible, very nice, but it remains in the same place. So but yeah, no, but you have to then manually do it, and it takes time, it takes hours. And of course, if your exposure is too short, what you can do is at the beginning of the session or at the end of the session, take an image that it would work for having a nice well-lit foreground and a well-lit sky, and you can use that as your base image from where on which you're going to do the composition. So don't forget about that. That's important. Another parameter is important. Don't be afraid of bumping your ISO. That's just multiplying the signal, so it will help in most cases. You should know some cameras should not go higher than 1600. Some cameras are very comfortable at 6400. So noise reduction for long exposure should be set off to should be switched off. The reason for this is that if you have it on, for every image that you take, the camera will take another image that is called dark. So it's a black image, and so you're losing exposure time, and you will not be imaging. So that is done to reduce the noise in the camera, to reduce the noise that your sensor generates. Here, it's not going to be that problematic, and what you really want is image after image after image. Don't lose time doing that, because if you're exposing for 5 seconds, that will take another 5 seconds. So you would be losing half your time. And don't leave any gap between your exposures. Just set an intervalometer and put it unlimited, and then you switch it off whenever when you run out of memory, or when you're done. So the composition is essentially, I want to show you now some examples, and just to indicate that it's nice to have the radiant within your composition, but it's also nice to move away from the radiant. So a few degrees, between 30 to 60 degrees away from the radiant, you would be comfortably seeing multiple meteors. As I said, if you're going 180, as I did with the Perseids last year, you're at risk of just seeing 2 in, I don't know how many, it was 2 hours, an hour and a half, 2 hours, and I saw 2. But if you go about 30 to 60 degrees, you would still see a huge amount of meteors. The trails will be very long, so it will be really nice. So that's and there the typical hand rule to know more or less how many degrees away from the radiant. So just a representation there. So just to show you, so this is an image of the Perseids in 2018. From Teide Observatory. So one of the good things about being an astrophysicist is that you can get access to special areas. So it was taken with the Samyang 24mm f2.0. Every image was about 10 seconds. So the background and the foreground is just one image, 10 seconds with one meteor. And then what I did is I derotated the sky so I could see the effect of all the meteors coming from the radiant. And each image, so I took hundreds or thousands of images every 10 seconds, of 10 seconds each. And then the clouds came. So this was done with the radiant quite low, and or decently low, and I think it was only 2 hours worth of exposure because the clouds came, and you have that beautiful effect. I really enjoyed. Now this one was recently featured, or actually for the Gemini Meteor Shower, was featured in the Sky and Telescope magazine. And this one, what I did is I moved away from the radiant. So from Tenerife, the Gemini constellation crosses the zenith. So it's very difficult to find a foreground, almost impossible to find a foreground and the radiant and put a composition that would have both the radiant and a foreground. In this case, I wanted, you see, it's very similar to the previous image, although now I had the luck of having the telescope open. I also have this red glow, which is air glow, which is residual radiation from the sun interacting with the atmosphere. Again, red color because it's exciting the elements in the atmosphere. It's very similar to the process that happens in aurora. Now much fainter, you will not see it with your eye, but you can detect it. Well, so here, what I like from this one is because the radiant is away, you don't have the zoom effect. What you have is the shower effect. The trails are very long. They all seem eventually, they look almost parallel to each other, but you can see they kind of convert in one point, but you have this beautiful shower effect. Again, 24mm. Why? Because I want to give emphasis also to the foreground, and I want to make sure that I can see these trails. If I go to a wide field of view, this is a 14mm. So the 14mm allowed me to get a little bit of the radiant. The radiant was just outside. Now, here you don't have the zoom effect because the radiant is just on the edge, and you don't have the shower effect because you're covering a lot. So it's in nowhere's land. Now you can see these two really big beasts there. They were really bright, and they were so bright that they lit up, that we could see the reflection in the domes of this guy. Actually, I saw it lighting up. Now, because the 14mm pushes the foreground so far away, that's Mount Teide, which is just about 30 kilometers away or so, and it's almost 4,000 kilometers high, 4,000 meters high. Because the 14mm is pushing everything away, they look tiny, and these trails, they don't look that impressive as this ones, and that's because each pixel in your camera is covering much more space in the sky, so the whole sky is shrinking, And even long trails, they don't look as long. And also you can see that how some of them look rather faint, and that's because the lens is not as sensitive. And this was, as I said, one of the Canon lent me the USR, and I was just testing it with multiple lenses and multiple systems. And then sometimes what you can do in terms of composition is you can think of, is there any deep sky object nearby that I could zoom in and try to find a nice composition where instead of just worrying about foreground, I just focus on, you know, that part of the sky. If you look at here, you have Orion, you have the Pleiades, and this year we had a comet Virtanen. It was there. So I knew that the trails, that this region is far, not super far, but it's far away from the radiant. But I was hoping that if I zoom in there, I was going to be able to see some trails. Now, I thought we are going to be too far away and the trails are going to be crossing my sensor, but still, I tried. So now what I did is I used a longer focal length, so I reduced my field of view a lot, and because of doing that, I choose a star tracker so I could take slightly longer exposures. The longer exposures so I can track the deep sky object and I don't have to repoint, so I can track it there. The exposures, again, don't have to be super long because the meteor is just not gonna, you know, once it crosses, it crosses. So the duration of that will be the same. But since I'm narrow it down, I can allow the sky is not gonna be as bright for me. So these are 20-second exposures. You can see, and the background is one single 20-second exposure. I didn't do any, I do have multiple images. I could have done a total exposure of 1 hour on the background, where probably I would have had a much brighter comet, and definitely I would have been able to collect or show better the reflection nebula on the Pleiades. But I thought this was very straightforward. You know, you have one single image of 20 seconds in the background, no need to edit. The comet is there, the Pleiades were there, and then because also I'm tracking the sky, all I have to do is stack one on top of the other the images. I don't have to derotate the. In this case, I was using a Skywatcher Star Adventurer, so it's an equatorial mount. So as the sky is rotating, my star tracker is also rotating. So all I had to do was align the stars and overlay them. And to my surprise, I was able to detect a lot of teeny tiny trails. So tiny, these ones are so tiny. So this is a Canon 80D. It's at 50 millimeters. So technically the field of view is equivalent of an 85 millimeter in a full sensor. It's a teeny tiny field of view. If we put it here, I was looking at that. And some of these trails could have been detected by my 14 millimeters, but some of this one, for example, and that one, this one is quite faint. I was probably not gonna detect it with a 14 millimeter, but also it's so short here. Definitely, I would have missed it. So sometimes by doing this, so for example, I could have done the same with Orion, and it would have allowed me to have Orion and detecting a lot of meteors that with the 14 millimeters I was missing. So even here that I detected, I can't remember how many there are in this one. I think it's about 17 or 18. Probably there were more that I missed because they were too faint, because they were too small for my sensor. With the 24 millimeters, I would have had a smaller field of view, but I would have been able to detect fainter. I would have been able to detect a little bit shorter, but still zooming in, it allows me to detect even shorter trails. So it's up to you then to decide and to figure out a little bit, oh, you know, am I too close? Am I not too close? So for example, in the Perseids, Andromeda is really, really close. So zooming in Andromeda and having a field of view that covers a little bit more than Andromeda, it's likely that you're gonna have, like how I started. Let me go back to the beginning for a second. You know, like imagine that I would have zoomed in, I would have had my 50 millimeter or even a little bit longer focal length around Andromeda, taking nice shots. Well, I would have had a really nice photo with Andromeda, nice looking, and this one passing just on top of it. So that's one. And for the Gemini, the other nice object that is really nearby is the Heart and Soul Nebula. So some people try to aim at them and do a nice composition, spend about 2 hours just photographing them every 20-30 seconds. Then they stack all the data to have a nice Heart and Soul Nebula, and hopefully during that time they have that's actually really close to the radiant, so there is a big chance that you would detect at least one crossing it. So thank you very much for your attention. Thank you very much for inviting me, and yeah, I'm happy to answer any questions.
Antonio, thank you for a wonderful talk. I've often tried to take images of meteors, and it's been a resounding failure, but you've enthused me to go and have another go. So thank you for that. And also, I've got to say, I think I've been a member of Metsman and Swinton for getting on to be about 17, 18 years now. And you are the first professional astronomer who's actually shown his own photographs taken with equipment that any of us could have. So thank you for that. It's been a real pleasure to see a professional astronomer's images.
Well, thank you very much, because that is one goal on that I do. That's something that is, for me, is very important. So that feedback is fantastic. I teach a lecture in my university first year astronomy to a large cohort of students, and these images go into my lecture. I always felt that if I showed them my own images, and I remember a few years ago when I started, someone said, could you add a little palette, a little sign that says, AMC, so we know that's your image. And so I have it there, and I have seen that they engage much better with that material, because I guess what you just said, it feels closer. It feels like I can do that, and now I know what it means to do that, and so I really appreciate that comment.
Yeah. Well, it's got to be said that a lot of our speakers do confess that they're not actually too sure where the object they're studying is in the night sky. So it's nice to come across somebody who actually knows the way around the night sky as well.
Yes, it wouldn't be the first time. No, it's very common. It's like, your object is there. Oh, really?
Okay, ladies and gentlemen. So I'm looking for hands for questions. Has anybody? I'm sure somebody's got a question. Sean Reynolds.
Hello. Yeah, thanks. That was a great talk. Really enjoyed that. What can you just ask you what software you use for derotation? Sky derotation?
Okay. So for the derotation, I'm using Photoshop.
Oh, okay. Yeah. Yeah.
So if give me just one, give me a second, because I don't have just give me a second so I finish.
Yeah, sure.
That. Yeah. And then where am I now again? Here. I'm making a mess of this, because I had a longer talk once, so I hope you can see my.
Yeah.
So here.
Mm-hmm.
So essentially, what you have to do. So you see, I had a longer. So this is also part of a course that I do on how to photograph meteor showers, and there, it's a 2-hour webinar on this. So I had much. So I also talk about how to do the stacking. So if you have the Polaris, it's great, because what you do is you use all your images and you do a star trail. And this is something that I always say. You never leave empty-handed from a meteor shower hunt. If you do it properly, at least you will go home with a star trail. So you stack them all up and you end up with a star trail. So at least that. But if you have that is going to help you find an anchor point on Photoshop, so you can use. Because you cannot just rotate the image whatever way you want. You have to use the free transformation in Photoshop, the default one, but move the anchor point to where Polaris is. So in this case, it was very easy because it was there. If you don't see Polaris, what you do is you create some circles, and then you put the anchor point where you would see the concentric part of those circles, and you say, well, that's going to be my anchor point when I'm rotating, and then you start rotating around. So in this case, for example, you know, I had another star trails. I mean, this is not all the images that I had. And this star trails is really nice because you have the celestial equator, you have stars rotating around the South Pole, you have stars rotating around the North Pole. So, you know, it's not only the meteor showers, you get much more out of it.
Yeah, cool. Yeah, thank you very much. Cheers.
Thank you, Sean.
Thank you. Cheers.
John Leach. Unmute yourself, John. Unmute your microphone.
Okay.
Okay. Your question, John.
Antonio, that was brilliant. Well, I'm a photographer and I've been for many, many years. And I've had a similar experience with 3 Canons set up in the garden doing comments and stuff. I've recently moved over, Antonio, to the Olympus system, which has the starry sky focus, autofocus mode. Because what I was getting with the Canon, occasionally my images weren't sharp, even though I did all the, proper procedure for actually getting sharp images for looking at stars and whatever. But I must admit that the Olympus system, new one, this starry sky autofocus, is absolutely spot on for stars and anything up there. Have you experienced with this, or?
I heard good things of the Olympus in that regard. So I originally had some issues with focusing. Then I learned about the hyperfocal, which is not 100% right. It's not infinitive, but the hyperfocal means that for 14 millimeter lenses and 24 millimeter lenses, if you there are tables, and if you focus to the hyperfocal, essentially you have from 2 meters, you have a focus done from 2 meters almost to infinity. Yeah. And that, so that was very easy because, and you can be kind of like approximate. So essentially I got a torch, I lit up a rock that was about 2-3 meters away, depending on how much my hyperfocal was. And I focused very well on that because it's really nearby, and then I assumed that was going to be more or less my focus for the infinity. And that started to give me good results. Now, some people will say, really, if you want to be accurate, the focus on infinity is slightly off. But that said, recently I got the Canon EOS R, the RA, sorry. I got the RA. And the RA has a zoom of 30 times. So it's specifically for astrophotography. It has removed the filter, although you can also use it during daytime due to software that they have put in there. And they changed the zoom. So instead of just going 510, you go 530. So you get so much zoom that really I never failed the focus on that camera since I got it. Yeah. And then also the focus peaking on mirrorless cameras is helping me because it even detects the stars. Now, it has but it works quite well. So I heard good things of the Olympus. I haven't had the chance of having it in my hands, but I heard good things on a few things that they do for astrophotography. But I'm happy now with my setup. Yeah. One, because I got really used to it, and now with the RA because I have the 30X, and I love it so much.
Yeah, I mean that's a nice thing because I've still got both systems, and of course with the Canon you've got the 1.6 crop. Mm-hmm. Which is better for that type of thing, and then the Olympus, of course, is 2 because it's 4 thirds, and of course that's got its advantage if you're doing things like lunar photography. Mm-hmm. So you need both in your armory, so to speak.
But one thing that I always also say to people with Olympus, and like I come across a lot of people with crop sensors, and I started with a crop sensor for many years, is sometimes invest on a star tracker and do Milky Ways, landscape Milky Ways with a star tracker. Then you can expose, you put an Olympus or on a crop sensor, any 1.6, 2, doesn't matter. You put a 14 millimeter there. and your field of view might shrink, but you put it in a Star Trek and you can put 30 seconds, 1 minute exposure. And then of course you have to take another exposure for the foreground. So you take one exposure with the tracker still for the foreground, you have it that, and then you track the sky, and then you do a composition of the two, and you get results that are amazing. And Star Trackers cost like a lens. So sometimes a lot of people email me like, should I get this lens? What lenses do you have? No, it makes more sense you would have much more fun with a tracker now at this point.
Can I ask one more question?
Certainly can.
You use Photoshop, Antonio, which is what I use. I used to teach Photoshop. And of course, with astrophotography, the resulting image is normally, it's an interpretation. You know, some people will spend a bit more time post-processing to give a more vibrant and maybe a darker, a bluer sky. And that's always, there's no real set standard for the final result of an astrophotography image.
Mm-hmm.
What have you got any views on that?
Well, so I have my own standards, and I respect other standards. I think if someone is changing the colors too much, I'm happy for them to do it as long as they are honest about it. So we are on the fine edge between being realistic and being art. And as art, you can do it. I mean, I also do a space deep sky object astrophotography. And in that case, you're using 3 filters. And it could be 3 broadband filters like red, green, blue, or you can use narrowband filters like hydrogen alpha, oxygen 3, and sulfur 3, or sulfur 2. And when you're using the narrowband filters, well, you know, the color is not going to be realistic. It's whatever you want to make it, because, you know, it's extremely narrow. Actually, hydrogen alpha and sulfur 2 are quite close in the rainbow. They're both in the red. So you would have to make one green and the other red, but technically none of them are green. So then that's what we call false color image, because, you know, you're making it whatever. You just want to highlight this more, you want to highlight that more, but you're honest about it, you know. Now, with landscape photography, like, for example, that one, I try to be as honest. In my opinion, I try to be as honest as possible. Now, I can try to get the Milky Way as realistic as possible, white balance, and then maybe add a little bit of a tone. I mean, I'm known for adding sometimes a little bit of a bluish, you know, maybe leaving it a little bit cooler. Yeah. But that's just a white balance thing. Maybe leave the foreground, giving it a little bit of extra boost. You know, like somehow someone could say you're lying, because now in post-processing with Lightroom or Photoshop, you're adding a little bit of brightness to the foreground and leaving the background. Yeah, but the photons are there. It's just I'm adding more dynamic range. Your eye can adjust, but the camera is much more limited to dynamic range. So I'm not lying. I mean, the eye is never going to pick up some of the things that we get with the camera anyway. So, you know, technically you're lying from that moment on. But I try to keep the colors real.
Yeah, my thoughts exactly. Thank you very much indeed, Antonio.
Okay, thank you, John. Any other questions? Trevor Worrell.
Antonio, thanks for a really interesting presentation. Lots of things to go away and play with, really. I just wondered if you'd come across any of these low light level DMK range CMOS detectors that can record an area of sky, and then the software seems to be open source, and it just watches for these meteors crossing the pixels and then goes, that's one, and records a packet. I wonder if you've got any experience of those.
No, I've seen it. We work, so I work on, I'm trying to build virtual all-stack using CMOS, and for scientific purposes, and also in multiple areas during the day for meteorology, how clouds form and evolved and dissolved, and at nighttime to pick up fireballs and pick up these things. And I'm aware of that kind of software, and I am aware of the limitations currently with satellites. So I know that they are picking up a lot of satellites, because so I know someone who's working on this software, Now they know that what they have to do is look on the previous image, look on the next image, and if there's a trail on all three images that is moving through space, it's likely, like use it as a rejection method. But it's not working. And my experience last summer when I went to hunting for meteors is that the number of satellites we have in the sky is overwhelming at this point. I mean, I would say that from, I think every image that I took for the Perseus had almost every image had satellite on it, almost. So they have their issues, but it works well. Now they work also better with the large field of view. So when you narrow it, it gets lost a little bit. But yeah, no, it is a way that to minimize the workload once you have all the images. It could work. It could work, but I haven't done it myself.
Okay, Trevor. Thank you. Tony Morris.
Hi, just to give Trevor some information, if you look on the web for the nematode network, the BAA nematode network, that's the network of all sky cameras using the software that looks for meteors, Trev. And it's pretty good.
I'm taking note of that one.
Okay, thank you, Tony.
Tony.
And I'm looking around for questions. Phil Muffet.
Yeah, good evening. Sorry I missed the beginning, but that was a lovely talk.
Thank you.
So one of the things I use Meteor Active to predict the meteor showers and which ones are good. Well, they're not always accurate. So I've started on an evening. I'm using Meteor Scan, which is from the Norman Lockyer Observatory in Devon. They use live data streamed on the net, and minute packages after it's happened. So even though you might think there's going to be a major shower, sometimes there isn't. Well, it gives you up-to-date activity, and sometimes it's really, really active when it says that there's not supposed to be any activity. So I've been using that to pick on what's going off at the time. I think the range is about 25 an hour at the moment, and it's really, really up to date, and I found that really, really useful. Yeah, it's interesting, and I've started using Nightcap to do the photography, although I must admit I've not been successful with the Nightcap on the iPhone as what I have been with the Canon D50, whatever it is, doing the 30-second exposures. And I also noticed as well, the Perseus tend to have the green tinge in the atmosphere, but I think you took some photographs, was it the Geminids, that were raining down vertically, and they all seem to be white, and you don't seem to get a tinge as they hit the atmosphere. They seem to the same color all the way through, and you kind of get a depth of the atmosphere as well when they're in vertically, rather than looking into focal points as they're coming from a radiant. Do you get the same effect? Do you see the same thing?
So to start from that part, so in the case of the Gemini, so if you blown out the amount of information, if your sensor picks so much information that you essentially lose information, you're going to lose the color. So in that case, it's not that the green wasn't there. It's just I didn't. The meteors were bright or too faint to greater or too bright that I didn't. I lost it. And the reason why they look so vertical is because the radiance. So you have always the same effect.
Yes.
You're looking at. But imagine now that my hand is on the zenith, because in that case the radiant was pretty much at the zenith. So if you look up, you see the zoom, but if you look towards the horizon, then you just see them vertical, and that's what I was doing.
My point is, you get a depth.
Yes.
To the atmosphere has been through where you don't when you're looking at a radiant point.
Yeah, by that time it has crossed a lot. Yeah, it goes more shallow angle. So essentially, but you're also more likely to see the green in that case, because the tail is so long that it has a lot of interaction. It's just in my case I was unlucky that I didn't maybe if I would have lowered. So one thing that the picking a high ISO does is it multiplies the signal. So you have less range at which, you know, without saturating the image. So it's easier to lose that color. And in terms of finding the rate, it's very easy. There are tutorials out there to build radio stations, radio antennas in your back gardens to just pick the activity of meteor showers and be able to, and then you can collect it during the day and during the night because it's radio, and you can actually measure activity by yourself. And there's a huge community out there doing it. It's very cheap and very, very easy to do. You put it on the roof or you put it in the back garden.
Antonio, please do not encourage him. He'll start talking about it.
I've done it. I've built one.
He's got the t-shirt.
Yeah, I use the French radar in Dijon to to receive them, but it's easy to look on Meteor Scan because I don't have to get my equipment out there.
Okay, thanks, Phil. I'm looking around for questions. I'm not seeing any digital hands. So just one quick scan round everybody. No. So, ladies and gentlemen, can we thank Antonio for an absolutely first-class talk and re-enthusing us about going out and taking images of meteors. Antonio, thank you very much, sir.
Thank you very much. Thank you. Thank you very much, everyone. It's a pleasure.